Good morning, or whenever you're watching this video. Hello, hope you're having a great day. I'm trying to get this done in the morning for the first time, so I'm kind of squeezing it in here between my high school classes. The glare on the windows hasn't quite come in yet, so I'm hoping this will work out just a little better. All right, today's lesson is 6.3. We're going to add and subtract our rational expressions, aka our fractions, but in this section, all of our denominators will be the same. So we call those like denominators. If you kind of glance at the problems, you'll notice that all of the denominators match. And so when that happens, the denominator isn't going to change. What we will do is we will apply the operation to the numerator only, and the denominator just kind of follows along for the ride. So I started us off with something kind of a review from our K-12 days here. We have 5/7 plus 1/7. And so just to illustrate, we're going to add those two together. 5 plus 1 is 6. And our answer then is 6/7. We just kind of follow that along, and that can't be reduced at all, so that is our final answer. Immediately in example B, that increases in level of difficulty. However, the process remains the same. So if I have 3x plus, and I'm going to gather here any like terms, so there is a 1 there. So 3x plus 1x, I'll write the answer underneath, is 4x. And that minus 6 just goes along for the ride. And then x plus 4 is the denominator for the problem. Can I factor anything? Is there a way to reduce that answer? We can always check. Some of those will happen over here. So you do have a GCF in the numerator. We can pull that 2 out front. But as you can see, nothing is going to cancel. There's nothing you can reduce. So both answers are equivalent. Either one would work for me. Moving on. Let's look at C. Now we have something even more complicated in our denominator. So when we see something like that, think factoring. Once again, we need to always reduce our fractions. And the way we reduce our fractions is to cancel out any common factors. So when I add the terms in the numerator, I end up with x minus 3, a negative 5, and a positive 2. And then we can rewrite the denominator here, or if you can see that denominator will factor, you can go ahead and factor it right here. So x plus 3, x minus 3. And I just want to make sure I'm not going off camera here, so that's why I chose to erase it and not rewrite it. And so my x minus 3's, you see, will cancel. And so my final answer, hopefully you can still see this, is 1 over x plus 3. All right, if that is off camera, because I don't want to end up having to go and check, it's 1 over x plus 3. All right, 5 and 6 change, or D and E, change it up just a little bit. Gosh, I'm not even counting correctly, am I? This is the 4th and the 5th example. Notice your negative. When you are subtracting fractions, you need to distribute that negative to everybody in the numerator, meaning that this is going to become a negative x and this is going to become a negative 13. And you can go ahead and write those negatives right here. You can erase, you can change this to a positive and erase those and change the signs, or you can rewrite the whole thing. It's going to be 5x minus 13 over x minus 1. And so if you want to rewrite that, you can see it all, and now you can gather up your like terms. And so 5x take away x is 4x minus 13 over x minus 1. 4x minus 13 doesn't factor, so there's no reason to try to factor it or cross anything out. That is just done. On this one, again, you notice the negative, so it's not a difficult concept, but it is one that students, it's easy to overlook. So another reason why I like those parentheses there, because it's just a nice reminder that I need to distribute. So you are going to change this to a plus, and then everything here changes signs. So here's another way to do that. That's what I was talking about with just the erasing piece. And so let's look for our like terms. Well, I don't have any other x squares, don't have any x terms, and I don't have any constants. So this is the whole numerator over x minus 4. Does our numerator factor? Indeed it does. Two numbers that multiply to negative 12 and add to negative 1 are negative 4 and a positive 3. So we always are going to check to see if things factor. And then these common factors will cross out there. And so my final answer here would be x plus 3. So that is the first half of section 6.3. The second half of the section prepares you for 6.4, where the denominators are not the same. And so again, when you think about your history in K-12 with fractions, and you had to find a common denominator, that is what we are going to do in our next unit. But this unit does some setup work for that. So finding what's called the least common multiple, aka we refer to that as being the common denominator. So we're not actually doing the operation in section 6.3, we're just practicing how to find that common denominator. So our instructions for the second part will be find the LCM. And they're going to give you two simple, well, it's not going to maybe seem simple to you at first, but something like this. And then something like this. All right? And here is what I would do until you kind of get the hang of it. You don't have to, if you know of a different method, that's great. I'm just trying to give you one strategy. My strategy is not the only strategy. So the steps I would use is break it down into factors. And we call the least, like as far down as you can break it, prime factors. So break it down into prime factors. All right, and each factor needs to be in the LCM. And you choose the largest string. And I will explain what I mean by that in just a moment. So you choose, if one factor comes up multiple times, you choose the more times the higher exponent for any particular factor. So let's start here. We'll break this one down. 12 is 2 times 6. 6 is 2 times 3. And so 12 can be rewritten as 2 times 2 times 3. And then if I break the x's down, it looks like that. On the other side, 18 is 2 times 9. 9 is 3 times 3. And so 18 can be written as 2 times 3 times 3, and then I can do x times x to represent x squared. So I need to make sure that all the factors show up. So it looks like my only numerical factors are 2 and 3. And then I'm going to choose the larger string. So since I have 2 2's here, my LCM needs 2 2's. Since I have 2 3's here, my LCM needs 2 3's. And then I have 2 x's here and 3 x's here. You're going to choose the larger number of times. And now you can remultiply. So 2 times 2 is 4. 3 times 3 is 9. 4 times 9, it looks like my LCM would be 36 x to the third. Let's do it again and see if you... At any point, if you want to try it, you certainly can. I'll leave the steps up here. Let's try this again. Our instructions are going to be to find the LCM. So I'm going to try 15a. And my other expression will be 24b. Break down 15. 15 is 3 times 5 and then times a. Break down 24. 24 is 2 times 12, which is 2 times 6, which is 2 times 3. So I don't have to write out that factor tree if you don't want to. You do whatever works for you. It looks like I have 2's, 3's, 5's, A's, and B's as factors. So I need to make sure all of those numbers I see are represented. Since I have 3 2's here, my LCM needs 3 2's. I have a 3 there and a single 3 there, so I just need to include it once because it never shows up more than once. I need to make sure I include that 5, that A, and that B. So my common denominator, if these were denominators in some fraction and I wanted to add or subtract them, my common denominator would be 8 times 15 is 120, A, B. That would be my LCM. Let's try this one more time, and we'll try it with trinomials this time, so you kind of see where we're headed with this as we go into 6.4. Sorry, I didn't write those instructions. It kind of says up there, find that LCM. We're going to look at x squared plus 5x minus 6 on one side, and then we're going to look at x squared minus 1 on the other. So same idea, it just looks tricky. So go ahead and factor. 2 numbers that multiply to 6 that add up to a positive 5 are going to be a plus 6 and a negative 1. X squared minus 1 is the difference between 2 perfect squares, so we have x plus 1, x minus 1. And every factor needs to be included. So my LCM is going to be x plus 6, x minus 1, and x plus 1. And you can write those in any order. And the good news is that you don't have to multiply them out. So that is your final least common multiple, or as they say, common denominator. So go ahead and practice, and good luck. Hope you have a good day.